Imagine witnessing the most violent events in the universe, black hole collisions, and using them to test the very fabric of reality. That's exactly what scientists have done, and the results are mind-boggling. The LIGO-Virgo-KAGRA Collaboration has detected two unprecedented gravitational wave events, GW241011 and GW241110, which occurred in October and November 2024. These observations aren't just breaking records, they are reshaping our understanding of black holes, the ripples in space-time, and even the fundamental laws of physics as we know them. But here's where it gets controversial. These events suggest that some black holes might not be first-timers in the merger game. Instead, they could be second-generation black holes, born from the remnants of previous collisions. This idea challenges our traditional view of black hole formation and hints at dense, dynamic cosmic environments where these behemoths interact more frequently than we thought. And this is the part most people miss. These findings also allow us to test Einstein's theory of general relativity and hunt for hypothetical particles like ultralight bosons, which could hold the key to understanding dark matter. GW241011, detected on October 11, 2024, involved black holes with masses 17 and 7 times that of our Sun, located 700 million light-years away. What's astonishing is the spin of the heavier black hole. It was rotating at a staggering 75% of its theoretical maximum, the fastest ever observed. The second event, GW241110, featured black holes of similar masses, 16 and 8 solar masses. But with a peculiar twist, the larger black hole was spinning in the opposite direction of its orbit, a first-of-its-kind observation. These unusual configurations have scientists buzzing. Stephen Fairhurst, spokesperson for the LIGO Scientific Collaboration, calls these events among the most novel ever observed, providing tantalizing evidence for hierarchical mergers. Meanwhile, Gianluca Gem of the Virgo Collaboration highlights the global effort behind these discoveries, emphasizing how international collaboration is unlocking the universe's deepest secrets. But it doesn't stop there. By analyzing these events with unprecedented precision, researchers tested the limits of general relativity and probed the existence of ultralight bosons. While Einstein's theory held strong, the door remains open for new physics. As Carl-Johan Heister, co-author of the study, explains, we are now more sensitive than ever to phenomena beyond our current understanding. So, here's the big question. Are we on the brink of a new era in physics, where black hole mergers reveal not just the universe's history, but also its hidden rules? These discoveries, published in the astrophysical journal Letters, are just the beginning. What do you think? Are second-generation black holes the norm, or are we witnessing rare cosmic anomalies? Let's debate in the comments. The universe is waiting for your take.